This is a little flight controller I've had for a while. I haven't said anything about. It's an M9N-F4-3100. It's basically a GPS module with an F405 flight controller on it, in addition to the GPS compass module. So I've just been asked some questions by a viewer about one of these. So I'm going to try to sort of work this up. I think I'll fly this either in the Titan Talon or the other Skyhunter behind me I have to build. I'm not sure yet. I'm just going to sort of work it up. But let me show you how to get started with this creature.
This is the Matek site for this particular flight controller. There's two versions of it, the 3100 and the 5883 version. It's just got a different compass GPS module on top of it. But basically it is a F405 can. So if you look right here, for Ardu, plane, copter, and rover, we want to use Matek F405-CAN firmware. And that's the same we use for iNav, F405 CAN. So we'll go over to Ardu Pilot real quick. Documentation, downloads, whoops, firmware, plane. We'll go down to the stable 3.1 version, and we're looking for a Matek F405 CAN. Right here it is, Matek F405 CAN. And I'm going to take this one, because I think I might need that one. But I'm also going to take this one. I know this one will load in iNav for me on this particular flight controller. So we'll try to use Ardu Plane APJ. Well, let's see if we can get that firmware on this flight controller. Go over here into setup, install firmware. I'm going to go ahead and plug in the flight controller. You can see right here it found it. Really need to be in this screen before you do that. COM18 is correct. We're going to try to load that custom firmware, and I usually, like I say, I have to use this APJ for that. Please unplug the board, press OK, plug the board back in, sure. Off it goes. So this is the F405 CAN firmware. Got to make sure first you get the correct firmware on here. Now then, my Windows 10 computer is probably going to call this an F765 wing. What do you want to bet? So there's the upload of the current version of Ardu Plane onto that hardware for the first time. We'll go ahead and unplug it, plug it back in. We'll connect to it. COM18, yep, see, thinks it's a F765 wing. Pay no attention to this whatsoever. It's just what the COM port thinks it's connected to. Has to do with Windows 10 or 11. Don't get hung up there. Make sure you use the Matek F405 CAN firmware. So let's see if this creature works and connects. Ba-boom. And we're up on Ardu Plane version 4.3.1. So there's, I don't have a GPS hooked to this. It's nothing hooked to this. So this is just my first access of this flight controller. So first of all, I'm going to come over here into the full parameters list, and I'm going to save to file. I've never saved for this one, so inside Mission Planner parameters, I'm going to have to make me a new platform flight controller for a, don't know what airplane it's going to be in right now, so we're going to call this an M9N, whoops, capital N dash F4-3100 flight controller. When we find a platform to put it in, we'll change that to probably it'll be the second Sky Hunter, but we'll see. So right here we're going to save, oops, how am I saving these? Have to see the format of how I'm saving all this so I can keep it uniform. Yikes! Keep it uniform across all of my work. So back to the M9-3100, we'll call that 431, and we don't yet know what platform it'll be in, so we'll just call it M9N-F4-31, oops, 100, again, 431. So basically what I'm doing with this is the platform in the first part of this, and then the version of the firmware. So there is, well, this should be the same now, a copy out of my parameters from a fresh install of 431. Now I can go in and start configuring everything on this. Let me look and see what I need to do.
So the first thing I'm going to do here is go in and get my ground in 5 volts for my receiver. I'm going to get it right here. This third pad over is ground, fourth pad over is 5 volts. That's because I'm going to attempt to use TX2 right here for CRSF. But first I'm going to do my ground and my supply voltage right here. And there's my ground and supply voltage connected. I'm going to use TX2 and RX2 to the left of it for CRSF. And I'm going to use RX5 and TX5 out on the right for my Mavlink when I get to that. But right now that we've got that sorted up, got a little bit of wire sticking towards that. Have to check that with a solder helper. Anyway, I'm going to power it up now and see if the receiver powers up with it. And there you go. I just hooked up the USB power, and I have good power and good ground on the receiver. I'm ready to move on.
And my next step is to set up the pins on my receiver. Now I am using a Nano Diversity. I'll try to get a different one up here in a second and use a Nano SE. But for this moment, I don't have an SE I can do CRSF and Mavlink both on without a lot of soldering like I can on this Diversity. Sorry about that. So first off, I need to put the receiver in binding mode. Now we've got the receiver in binding mode. Sorry you can't see that. And we'll go into the micro TX here and try to bind this to it. Okay. We have the two bound now. So we can come back out and we'll find the Nano Diversity here now. Evidently it's up to the current firmware because it did not ask me to update it. Yep, 619 current. So inside here, myself, I always do 12 channel mode, telemetry, dynamic cut. All this is cool. Nothing here. Output map. Yes, I want to use CRSF on 1 and 2. I'm going to set this to 2 for just a second and see what this allows. Okay. This is what I wanted to find out. So on output 1, I can only set CRSF transmit. I can't set receive on 1. So, seeing I can't, I won't. And that'll automatically make 2 receive. And for right now, I'm not going to come in here on the next 2 pins and do my Mavlink. I'm just going to get CRSF running first. Channel map. That's all fine. Okay, all this is fine now. Nothing else here to do. I am doing this because, let's see here. What I just did is I hooked my receiver ground to this pad right here, and I hooked my receiver 5 volts to this right here and powered it up. Use this ground and voltage to bind it to my transmitter. Now I'm going to use transmit and receive over here. So I want, let's go back and look at that for this. There we go. I want, okay, my pin 1 is transmit. So I want the 3rd wire, which for me is yellow or green. God, yellow. Transmit. I want it to go to this receive right here. And I want pin 4 here, which is blue for me. Receive out. I want to go to the transmit pin right here. So that would be blue and then yellow. Let me solder that up and see what we get. Let me tell you real quick the reason I did that. Over here in flight controller mapping, and you start getting down into these UARTs, what you're going to do with them and stuff. Come into the UARTs right here. You'll see right here it talks about CRSF. Serial 5 for Ardu Pilot. And that's TX2 and RX2 on the flight controller itself. That's what we're going to use for CRSF, TX2 and RX2. TX2 and RX2. So I need my transmit, this pin, going to receive this pin, and my transmit out of the flight controller going to the receive on here. So blue and yellow. Let me solder that up now. So the yellow transmit out of the receiver goes to receive on the flight controller, and the transmit out of this flight controller goes to receive on that transmitter. Let's see if we have CRSF working now. So the first thing I'm going to do is come into Mission Planner. I've got the transmitter back in my radio. I'm going to connect to the flight controller. We'll go into Setup, Mandatory Hardware, Radio Calibration. I'm not going to worry about my switches. I'm going to just use my joysticks right here in these 4. And you can see CRSF is working perfectly for me. I have not yet changed the perimeter in the flight controller. It is straight as it would be when it is just taken out of the box, flashed with Ardu Plane 4.31. Let's see real quick here if I have any telemetry yet. So to see if we have CRSF telemetry, we'll come into
the telemetry portion of the radio. Oops, there we go. And we will say, discover new sensors. Boop, there they go. There's the beginnings of CRSF telemetry with a limited number of telemetry values that you can get. Oops, I guess I need to go down here and tell it to stop discovering. I'll have to reset it up again for the nano talon, which was what this is for. So that proves that I have wired up CRSF correctly. I have CRSF radio control right now, and I have CRSF telemetry going between the receiver and the radio. At this point, you could do your Yahoo, anything you want to do that has to do with the radio telemetry. I'm not as interested in that telemetry as I am telemetry down to my ground station, mission planner, Q ground control, etc. So now I have to set up a second telemetry stream on this flight controller. And I'm going to set up a full Mavlink telemetry stream in addition to my CRSF telemetry stream. So I'm going to have two telemetry streams going at the same time. CRSF limited, about 20 data points, 20 different sensors it transmits, and Mavlink full, hundreds of data points that it transmits. So let's look back at our flight controller real quick.
And what we're going to be looking at is back over in the flight controller mapping. We're back down in the UARTs for kicks and grins here, because this flight controller has a limited number of UARTs, and we just used one up for CRSF. So the USB connector, serial 0, TX1, TX2, that's a user for 3. 4 is dedicated already to the M9N module, GPS/compass module. 5 is available. We use CRSF. That's it. There's no more UARTs on this board. So we could use 5, 3, or 1. But as you saw, I already got my eye on, and it might not work. We don't know. I already got my eye on using 5 right here for transmit and receive. So now then I would have to go back into my RC receiver and set up a Mavlink stream in addition to the CRSF stream I already have. And that CRSF is doing both radio control and a small subset of telemetry right now. So now we can get back in here to our output map, and now I would want to come in here and I want to set up Mavlink, not serial TX, anything like that. Mavlink. And again, here it is. I can only set up transmit on pin 3. It's actually pin 5. 5 and 6 we're talking about now, because ground and voltage don't show in here. Ground and voltage is pins 1 and 2. This is actually pins 3 and 4. This would be 5 and 6. So I can only set up Mavlink transmit here, and that will again automatically set up Mavlink receive on output 4. So on the next wire over, which me looking at it is my green wire, my green wire will be transmit, and my white wire will be receive. Transmit and receive. I'm just trying to look at these and get them set in my mind. Green is transmit, so it will go right here. So green and white. My transmit will go to this receive, and my receive will go to this transmit. So let me solder that up and we'll see what we have now.
And there we go. We have our green transmit going to receive and our white receive going to transmit on the flight controller. That should be perfect.
Now that we have the device sorted, we have to go back over to our mapping again real quick and look at our UARTs, because iNav and Matek use the same UART numbers. In other words, here we have, basically this would be 0, just like it is here. So 0, 1, 3, 4, 5, 2's down here. But you can see Ardu actually, it calls serial 0 still serial 0. It calls UART 1 still serial 1, but it calls UART 3 serial 2. iNav and Ardu map these UARTs differently. So just because it works in iNav with the wiring doesn't mean it's going to work in Ardu plane, because it's actually, because of memory mapping, it's actually a different UART. You can actually see here UART 4, which is how you would address it in iNav. You address as serial 3 in Ardu. And I hooked up to transmit an RX5, UART 5. So I'm looking at serial 4 in Ardu. So right now, before we test anything, we have to come over here. We have to connect with our USB cable. And what was that? Serial 5 is actually serial 4. Okay. We're connected. So we come in here to config, and we're looking for serial 4. Serial 4. Right now that is set up for a GPS. Actually, it's our first GPS. Oh well, I already know in the back of my mind what problems could crop up if the GPS isn't seen first. But we're not working on GPS right now, so this isn't correct for protocol. This should be 2. And I've found that 115 works best here for most of them. We'll see if it works for this. So there's the first perimeter changes we're making. We're going to write those out. Those are the first perimeter changes we're making to this. So I'm going to save this, but I'm going to save it as a, just put TST on the end of it, so I know it is a modified parameters list. So now we'll disconnect here. We'll come out here. We'll go to Wi-Fi. We'll connect our Crossfire transmitter. Via Wi-Fi. There we go. Let's go back out here real quick just to verify we're connected. Oh, quit that. You're not supposed to be doing that yet. And we will 192.168. Is it 4.1? Yeah, I think it is 4.1. Bingo. We are connected to our Crossfire transmitter with the Windows 10. So now we can come into Mission Planner and UDP. Ah, look at that. It's already connected. Darn thing. I'm going to exit it so I can come back in and show it to you. And watch it. because it's UDP. As soon as it comes in, bingo, you see, as soon as it connects, it will start trying again. Now, don't love this connection. You can see right down here we have a link quality of 51%. And I'm not fully connecting. So there's several things we can do right now. We can cancel this, disconnect with UDP, go back and connect with our serial cable. And we'll go back into serial 4. Did I reboot? I think I did. I'm going to reboot right now for kicks and grins. Don't remember if I did. But I just did, so it doesn't matter. I would try this one more time. UDP 14550. You would have to put that in one time at least. Yeah, see, I didn't reboot. Sorry about that. And I can tell you, because this is staying 100% down here, and this is reading parameters in so well, I now have both a Mavlink and CRSF telemetry connection and a CRSF control connection. I have 3 different connections with this receiver and flight controller right now. And you see here, let's look at the packets real quick. 100%, 0 packet loss. This is a good connection. This is on a nano diversity. This is not a pro. This has not got the extra transmitting power. These Crossfire receivers are not receivers. They're transceivers. They transmit and receive. Whoops, look, we had 9 packets lost. Ooh, 11. Ooh, that doesn't matter. Until it gets down to about 50, it's a good connection probably when you're flying. So this is a good connection. We can stop this. If you have 23 packets lost, you can't have 100%. But, so there's a UDP connection. Here's a USB connection. They both work the same. They're both Mavlink data. That's all the USB cable's doing, is using Mavlink to talk back and forth. The UDP connection's using Mavlink to talk back and forth. And if we come in here now and look at our full parameters and compare the default 431 parameters that were written out to this flight controller by defaults, we will find the only differences are, of course, there's going to be apparent differences in the barometer and the accelerometers, these first 4, because those values changed. It's not sitting in the same orientation on the bench, so you can always throw those away. And these 3 were changed. I'm not sure why, but they were changed by something we did. Wasn't anything I did by directly, but changing this serial 4 protocol from a 5 to a 2, from a GPS to a Mavlink 2 connection, and changing its baud rate from 38.4 to 115.200. If your connection doesn't do well, you can drop this down to 57.600. You can drop it down to 38.4. I wouldn't drop it much lower than that, and see if you can get a better connection because it's a slower baud rate. That's possible. Now, because I changed the serial protocol here. So it is serial 4, but it's the third serial device that Ardu's looking at. That's why it changed these 3 perimeters on the bottom, because I changed the third serial device from GPS to Mavlink. Ardu automatically changed these telemetry rates on SR3 for you. Don't worry about that. So that's it. Basically, I took a nano diversity and wired it to an M9N-F4-3100. It's hard to remember all this stuff sometimes. And the only 2 perimeters I had to change from out of the box was my serial 4 protocol and my baud rate. Now, had I used a different serial port, we would have been using a different number. Instead of serial 4, we would have been using the mapping for whatever serial port I used. Now, to close this up, I want to go back real quick and just talk about a Crossfire Nano real quick, SE, instead of this diversity. So let's touch this again real quick. Had I decided to use UART3, I would have gone into Ardu and talked about serial 2. I would have set my serial 2 protocol to 2 for Mavlink 2. Had I connected it to UART1, TX1 and TX2, that would have been straight up. Same UART1, serial 1. Cool. No problems there. But you see, Ardu already maps serial 3 differently. So, again, let's go look at a straight up Nano SE real quick. I've got one here. I can't wire those little bitty solder pads real quick on the fly here. And here's the Nano SE receiver. It has a little different mapping than the diversity I soldered to. You can set output 1 and 2 to see RSF transmit and receive, just like I did on the diversity. However, on the SE, you can only set 3 to receive. You cannot set 3 to transmit like I did on the diversity. It's just, you can't select it from the list. When this one is anything, oops, shouldn't have chose that. Okay, we got transmit and receive, CRSF. When you come in here to choose Mavlink, you see you don't have a transmit. You cannot put transmit on this one. And if you look at this one, you cannot put Mavlink receive on this one. So you have to. It's a limitation of Crossfire. You put receive on this one, and this one will automatically pop up transmit when you do that. So that's the only difference for the Nano SE from the diversity. And that should explain Crossfire, Ardu plane, CRSF radio control, Crossfire, CRSF telemetry. Oh, I need to show you one other thing about that. Excuse me, sorry. If we come back over here and look at our telemetry, you can see the values changing. So we still have our CRSF telemetry running in addition to our Mavlink telemetry. So to finish up here, I'd just like to add, this is the Crossfire manual for all of this. And if you come down in here to telemetry and available sensors with OpenTX, you click on that link. It's page 52 in their documentation. These are the available sensors through CRSF open for an open TX or Edge TX radio. Don't think it would make any difference, and probably other radios that do this. But this is all Crossfire sends. And I forget there's, I guess I could count them here, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Down to GPS is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 values, sensor messages it sends. Whereas with the full Mavlink set, you would have access to basically all of these, for example, and whatever of the full Mavlink set your platform might be sending. You can see here in this, I moved the flight controller around, and if we go in, we can find accelerometers someplace, because this list, if you look, I can go to the right, it is humongous. I mean, there's possibility of 9 different current sensors that you can be looking at a time, and Mavlink will tell you all 9 of them. True full Mavlink set is just absolutely crazy amount of data points. Right now there's no GPS connected, so our GPS status should be, oops, it says 1. No fix. Oh, there is a GPS on this. Wow, it's not 0. That kind of flipped me out there for a second, but yeah, that's true. It's on there, but it's not getting a connection. Looks like it's kind of set up too, without doing any parameter changes to it. That's pretty cool. It says no fix here instead of no GPS. I don't have the RC receiver hooked to it anymore, is why it's saying that. So that kind of flipped me out there for a second. The GPS status with none connected, you know, to me today I was wiring up a flight controller. I expected this to be a 1. It's not. I expected it to be a 0. It's not. It's a 1, showing there is a GPS found. Matter of fact, in messages over here, it will talk to us about that. 431. It thinks it's a 405 CAN hardware. I quit that. Art to plane 431. Compass not calibrated. GPS 1 bad fix. Let's try to look here where it found the GPS. It should here. Wow. Didn't say a word about it. Unusual. Usually it tells you here when it finds the GPS and what baud rate it connected to it at, etc., etc., etc. That might be because some of the messages and stuff need to be made a little bigger. But all the status over here, if we keep scrolling in that, you can see there's a value, and then, here's your link quality. With my USB right now, it's 100, of course. What's this? Oh, that's my horizon distance moving around. That's because we don't really have any real data coming in. Anyway, you can see what you get with a full Mavlink set here. Whatever variable sensor this is, vertical speed right here, version right here for current version of Ardu, and then the next column is what the value is for this particular variable. So it's a little more than 21. That's why I want it. You know, all of this is saved away to the SD card while you're flying. So if you get your platform back, you can cool. No big deal. If ever, however, you don't get your platform back, I like having this stuff right here, recording, so I can at least try to figure out why. How many batteries are they tracking now? 9 different batteries, even for temperature. Oh, man. Rangefinders. How many rangefinders do they actually track now? So, you know, if your platform goes out and runs away, you can use this to figure out why it did it, perhaps, so when you build your replacement platform, you don't do that same exact thing again. That's what you're doing. Only shows 3 rangefinders here. That's unusual. I bet you that's because they're not turned on. That's one of those cases of it doesn't appear unless it's enabled. Rangefinder 4. Huh. This goes through 10. This is hex. So this A means 10. So they're tracking 10 there. Anyway, so there's why I go for the full telemetry set. In case my platform doesn't return to me, I might have a chance to figure out what to do to prevent it in the future. I don't want to keep throwing airplanes, hexes, whatever, into the air and they run off someplace and never come back. It's expensive to do that. But if they do come back, having telemetry running as far as a telemetry radio, telemetry connection is kind of it's a little bit more important to have it down into your radio and stuff, because if they crash elsewhere, you can usually find out with a GPS fix. And I probably have to go into the parameters and do some changes for CAN. This truthfully is a CAN GPS, I think. No, it says it's set up on a UART. Anyway, this has gotten way too long. Just wanted to add some of those little tidbits at the end there. Have a good one. Thank you. Good night.